Here's the Geometry Chapter 3, Section 1 lesson about the properties of parallel lines. Open your workbook to page 49, and you'll see that I have on the screen the same view that you have in your book. So please fill in the blanks as we do it together on these pages. First, we'll talk about Postulate 3-1, the corresponding angles postulate. If a transversal intersects two parallel lines, then corresponding angles are blank. Well, wait a minute. We gotta go back here. We gotta talk about transversal and the parallel lines. If you have a transversal and parallel lines, it'll look like the diagram here, but here's what we mean. Parallel lines are indicated by having arrows on them. Sometimes it's one arrow. In this diagram, looks like there's double arrows here. And the transversal is the line that cuts through both of them. In the next section, on the next page, we'll realize that parallel lines are a special case of a transversal cutting through two other lines. For now, we're just using the parallel lines every time. So corresponding angles need to have two parallel lines and a transversal. So here they are, two parallel lines, transversal cutting through them. Corresponding angles mean that they're in the same relative location. So in this intersection, I'm using the top right-hand corner. In this intersection, I'm using the top right-hand corner again, but just on the other set of lines. So these locations correspond to each other. And so on your diagram, angle 1 and angle 2 are the corresponding angles. Now, here's the postulate. If the transversal intersects the two parallel lines, then these corresponding angles are congruent. And so angle 1 is congruent to angle 2. Next, alternate interior angles. This means that we've got two parallel lines cut by a transversal, and now the word alternate is our hint about where these angles are located in relationship to the transversal, and the interior is our clue about where the angles are located in relation to the parallel lines. So if I'm alternate, that means I've got one angle on one side of the transversal, the other angle is going to be on the other side of the transversal. And if I've got interior angles, then they're going to be on the inside, in between the two parallel lines. So alternate interior angles will be, for example, this one. Now I have to go to the other side of the transversal and stay on the inside of the parallel line. So here I go. This one and this one would be alternate interior angles. On the diagram, it will be angle 3 with angle 1. And those are alternate interior angles are also congruent. And so from our diagram, angle 1 is congruent to angle 3. Now, same side, interior. Again, we have a clue about where these are located in relationship to the transversal and where they're located in relationship to the parallel lines. So, two lines cut by a transversal. Same side means that I'll be on the same side of the transversal and in the interior, in between the two parallel lines. So I've got this angle. Now I have to keep on the same side of the transversal and be on the inside of the parallel line. So there we go. I got this one and this one. Angle 2 and angle 1 on this diagram. Now, do those look congruent? No. What's so special about them? What's special is that they are supplementary. And what's the definition of supplementary? The angles add up to 180 degrees. Next, alternate exterior angles. Well, two lines cut by two parallel lines cut by a transversal, alternate, meaning on opposite sides of the transversal, and exterior. So now I can't be on the inside of the parallel lines anymore. I have to be on the outside. So if I start with this angle highlighted, I have to go to the alternate side of the transversal, and I have to be on the outside of the parallel lines. So these would be your alternate exterior angles, and those are congruent. And in the diagram, you've got angle 4 with angle 5. Next, same side exterior angles. Two parallel lines cut by a transversal. Same side exterior means that I have to be on the same side of the transversal and be on the outside of the parallel lines, not on the inside. So if I use this angle, then the only other place that qualifies as same side exterior will be over here. And on your diagram, that's 4 with 6. Do those look congruent? Nope. They're supplementary again. So angle 4 plus angle 6 adds up to 180 degrees. Now, here are the definitions that we need.